Hi, this is Miss Litton, and this is 7th period support for Chapter 44, Population Ecology. I'm going to move quickly through the easy peasy, okay, so we can focus. I want to make sure you can do the problems, right? Did you do the practice problems? Did you try to do practice problems?
Yes.
And I added more in there.
Oh, you did?
Did you? Yeah.
I found a really good worksheet. It has like all the work written out, like not just the answers.
Right. I probably put that in there too. Look at it. It's all their work.
Oh, okay.
Yeah, check it in there as your reviews. Okay, you have to eat those quiet here because otherwise it's going to drive me crazy. Okay, so you, whoa. Why did that say, oh, play. Okay, play. Okay, so I can't read anything. So you understand what ecology means, right? We've gone over that about 1 billion times. How the organisms interact with their environment. Habitat is where you live. Niche is what you do. We got that. And then we talked about how the environment can influence the organisms and select which organisms can survive there, or the organisms have tolerance in order to survive there, and they in turn can influence the environment and change the environment, right? We're an organism that changes the environment, right? In cities and towns, etc., right? And then that can influence what other organisms can live there. We know this. Let's do it real quick. Atom, molecule, organelle. Do it with me. Cell, tissue, organ, organ system, organism, population, community, ecosystem, biosphere. Yay. All right, and we know those terms, so I'm not going to review those terms. I cannot see. And we talked about modern ecology as you're developing models. It's predictive. This is what could happen if you do this, right? All right. And then we talked about how do you study, so demographics of an area. So one of the things you can look at, we talked about density. So if you get a density problem, you just take how many organisms you have divided by how many acres, and then you have the density of that organism. Those are really easy problems, right? Okay, then the third one is the arrangement of that density. And so we had 3 different distribution patterns. And their names, like uniform, it's going to be uniform distribution. And if it's everywhere, taking up that whole area, then the environment must be the same. And there must be high competition, because that's why it's all lined out like that, like on a grid. If it's random organization of their density, then it must not matter if you're here or there. I will not eat green eggs. Here, yeah, sorry. And then there must be very low competition. But the most common, the most frequent form of density is what? Clumped. And you're clumped around what? Resources. Good. All right. So we talked about that. Then we talked about the rate of growth of that population. So we understand we can look at the density, the way that density is arranged, and then how quickly it grows. Right? And we looked at 2 different ways of growing, exponential and logistical. And they both have exponential growth in them. They both have lag and then exponential. But when you're looking at a logistic growth curve, it's starting to slow down due to what?
Carrying capacity.
Carrying capacity. Okay, so it's that carrying capacity is a set point pretty much. So it's slowing down though due to environmental resistance. Remember we talked about that? Slowing it down. Okay, so we can look and analyze things that affect, I'll come back to that, but we looked at abiotic and biotic factors can influence where something grows, right? Can affect its rate of growth. We looked at the distribution patterns. Can I go beyond that? Is that pretty easy? Okay. Okay, so then we talked about rate, okay, the rate of growth. So usually when you refer to R, usually when we talk about R, it's the per capita growth rate. So it is looking at what are the odds for you and your growth rate when you look at the birth rate minus the death rate, and that is how many births per 1,000 and minus how many deaths per 1,000. That's your R, your intrinsic rate of increase. And so you can take your population at any point and take that R value and multiply it by your population. Then you should be able to predict how big your population will be the following year. What's something that, how fast that population changes over time. Yes, all those factors, right? And how fast you're approaching, what's something that could, there's another letter in there. We're going to get to it in a little bit, but I want to just talk about it right now. Okay, now this one, you talk about K. Because its rate is going to slow down the closer you are to the carrying capacity, okay? So then we talked about that intrinsic rate, and we talked about its biotic potential. If you could maximize your biotic potential, and we talked about the 4 factors, right? When do you start reproducing? How many offspring do you have? When you do reproduce, how often do you reproduce? And what are the chances of your surviving? Those are all the things you take into consideration when you're looking at that rate of increase. When do you start? How often do you do it? How many do you produce? What are the chances it's going to survive? Okay? And we used words like cohort, and then we talked about survivorship curves. What are the likelihood that you're going to survive out your full lifespan? Not just reproduce, but survive your full lifespan, whatever that is. And we looked at 3 different survivorship curves. Type 1, type 2, type 3. And again, we're starting with 1,000 individuals. We're saying, what are the chances you're going to even live out your, you know how you could think of this? Remember when we looked at the pyramids and we, age structure diagrams? Remember pre-reproductive, reproductive, and post-reproductive? Remember how we looked at whether a population would grow or not grow? Remember that whole bit? Okay, so when you look here, most of these die off, their young die off, right? And when you're in type 3, you're not getting established somewhere, you're not allowed to hatch in some way, so most die, that's type 3. Type 1 is the absolute opposite of that. Most survive and most live out their full lifespan. And then type 2 is your death is not usually a factor of your age. You could be prey in a predator-prey relationship and you're just going to get killed. Okay? These are called survivorship curves. What's the key word in there? Survive. Are you going to survive? Okay? So this is telling you early death, death anytime, or die when you're old. Okay? Those are your 3 survivorship curves. That's different than, here are those age structure diagrams. Okay? An age structure diagram. So the 3 different ages we looked at, we'd already said pre-reproductive, reproductive, and post-reproductive. If you're heavy in the pre-reproductive, what's probably going to happen to your population? It's going to grow, right? Because you have a lot of pre-reproductive. If that's where the bulk of your peoples are in the pre-reproductive, what's the next stage? So you have more going into reproductive than are leaving it. If your number is smaller on the other side of reproduction than it is on before reproduction, then your population size is going to go up because more are going in than leaving. Right? A stable age structure diagram, the same amount going in are leaving. Right? So we looked at when you actually compare populations, it's not like you're going to, Africa's always going to be this or something, right? Because what did we say? These can transition, right? What are the ways to increase that transition to an age structure diagram that's stable is to what? What are some of the things we can do? Increase education, especially of women. I was like, ovaries, things with ovaries. Education of women. What else can we do? Try to decrease infant death mortality, right? That you want that, because if you start to see that they're going to survive, you don't need to have 5 kids hoping 3 will make it, right? You have 5 kids and all 5 make it, right? I would guess any one of you had 5 kids, chances are all 5 kids of yours are going to make it, right? It's not like, well, I hope 3 do. It's not like that. So if we can decrease infant mortality, if you could increase sanitation, right? Increase education, then that helps countries transition into the stable age structure diagram. And then we talked about there are different strategies on how, again, going back to your biotic potential, how often do you reproduce? How many times will you reproduce? Ms. Chevalier, how many times? Me too.
I was only twice.
Me too, I'm only twice. 2 and done.
But it could be 3, maybe.
I know.
You're probably stuck at 2.
These have been ligated. Sorry, folks, park's closed. Moose out front should have told you. Done deal for me. It would be.
Immaculate.
So, wow. Okay, anyway, I'm glad that was all recorded for your pleasure. Okay. So, we're tired. Yeah, we're tired. Okay. So we. Which one, top or bottom, would be large mammals or mammals in general? Bottom one. Yeah. Yeah, so we have iterations of when we reproduce, right? I've gone through the process twice. She's gone through it twice, maybe 3 times, right? Think of it as like iterations. Think of it like that, okay? It's not like once and done. Usually this is a very short lifespan, small, really. There, that could be like an R max individual. Remember how we talked about that? Am I making connections with you? Remember we said K strategist, R strategist? Do you remember that?
Yeah, like the Romans.
Oh, yeah, I did talk about that, but don't put that in the answer, yes. Okay, so then this,
Talks about Roman.
lend me your ears. Okay, eat and drink for tomorrow we may die. Okay, so then let's take all of that and put it together, what we've learned with our 2 kinds of growth curves, exponential and logistic growth curves. So exponential, just like it sounds, eat and drink for tomorrow we may die, okay? So this is usually one reproductive event, that's it, okay? Not your Semelparous, where you're just going to reproduce one time and probably die right afterwards. Then we looked at solving problems, okay? So we know what all those things mean, right? That's easy peasy, lemon squeezy, okay? So then basically when you look at a capital B, that is the number of like literal births, 20, 70, or literal deaths. Smoking hot right now. Are you guys not hot?
Yeah,
It
it's
says
pretty
it's
hot.
78 in here. Okay. Okay. And then when you get into here, you're looking at, when you get small b and d, then you're looking at number of births per 1,000 or number of deaths per 1,000. And then that can give you, when you take these 2 from each other, then you get R. That's your birth rate. If it's a positive number, if R is a positive number, what is going to happen to your population size? Increase. If R is a negative number, what is going to happen to your population? So if I have 500 in my population, regardless of the carrying capacity, and my R number, my R, my intrinsic rate of increase, is a positive number, then you know the answer the next month or year, right after the next year, then my population should be above 500, right? But if at any time my R number is negative, then the following year it's going to be what? Below 500. Whatever you calculate is going to be a negative number, you're going to take that away. So just get the big picture, okay? Positive R, it's going to go up, right? Negative R, it's going to go down. Okay? Now, how much it goes up is going to have to do with how close it is if you have some sort of what? Carrying capacity. I was making a K. Okay, it was super obvious. I'm sorry that they couldn't see it. But did I ever push start? Yeah, I did. Okay. Yeah, I did. Okay. So how close you are, it's going to slow down the closer you are to the carrying capacity, right? The farther you are away from your carrying capacity, you're not worried, right? The carrying capacity is not going to have a big impact. But the closer you are, it will slow you down. Okay? And then I already talked to you about this. So your change in population over time is your R max times N. That's if you don't have anything to do with carrying capacity. Yes, listening to you.
How do you know to use this formula versus the population growth formula?
This is the population growth formula.
Because on the worksheet that you gave us, there
Yes.
was like 2 different ones, and it didn't really
No. On the equation sheet that I gave you, that's the College Board gives you that. And it's really annoying. I don't know why they put capital B and capital D on that equation sheet. I cannot answer that riddle for you. But whenever you are given, if they ask you to calculate, if they ever ask you to calculate R, what are you going to need to know in order to calculate R? Birth rate, And what else?
Death rate.
Okay, what if, death rate, what if you don't have one of those? What's something else you could have?
You have the population.
If you have the change in the population, if you have that number, you can calculate it out, right? If you have the change in the population, you could work your way back. If you knew how big the population was and you had the change, you could solve for birth and death, right? Right? So you have both sides of the equation. If you're just missing one thing, you can solve for it. And one of the equations I ask you to, on your practice sheet, I ask you to solve for that. I think I have you solve for the birth rate or something. But you have the population initially and you have how much the population has changed. You're just solving for the one unknown. Didn't I ask you to do one of those? Yeah, birds, yeah.
So you shouldn't use that top one. You should always use the one with
You're always going to either be solving for R, okay, or solving for how much the population changed in relationship to the carrying capacity. Yes?
On the worksheet, could you go over?
Yeah, I'm going to do that. I totally want to go over that. That's why I was just going over this, and then we'll pull out the worksheets. Absolutely. Okay, and then let's move into here. Is this the one? No, I don't want to move into that. Okay, so here on your logistic growth curve, we're slowing down as we have some sort of environmental resistance. It's going to slow you down. And then this brings us to our logistic growth curve. What word do you hear in logistic? Yeah, so it's starting to slow down. And then, let's take a look at this one, okay? So this is, the D is for calculus, for, I think it's derivative, and it's like an instantaneous, at that moment, what could it be? You could continually to calculate. You can continually calculate. You're not asking for how many births do I have now, actual number of births or actual number of deaths, but you're calculating it based on, it's the same thing as before. All you're doing is multiplying it by one additional number, and that is how close you are, the percentage of how close you are to the carrying capacity. If you're really far away from your carrying capacity, really far away from your carrying capacity, it's like you're multiplying it times 1, right? If you're really far away from your carrying capacity, okay? And so if you're, because it'll be like carrying capacity over carrying capacity, right? If your carrying capacity is 500 and you're at 10, right? Let's say your population is 10 and your carrying capacity is 500. What's 500 minus 10? 490 divided by 500. So you're really close to 1. You see what I'm saying? The closer you are to your carrying capacity, the farther you are from 1, the closer you are to 0, right? Okay. Now, this is the equation sheet you're talking about, right? So you're asking me which one of these do you use? When you're looking at this one versus this. Okay, so this one right here, this is your absolute number. Do you see the D? Do you see how this is in italics and this isn't?
Yeah.
So if they're giving you, there were 20 births and there were 30 deaths, then the change in population is 10, negative 10. Yeah, that's when you would use that one.
Okay.
This is saying, this is a dynamic number. So this will change and add or subtract to the population every single year. I'm not talking about this right now, 10 gave birth to, I'm looking at it at a population per capita. Yes?
And that's when you have no carrying capacity?
No carrying capacity. And this, the only thing that's added on here is this. Carrying capacity minus N over K. That's the only thing that's added onto it. If they don't give you a carrying capacity, you're going to use this. Just R times N is going to equal the change. Right? What's my intrinsic rate of growth times what number I'm at, that's how much it's going to change. If they give you a carrying capacity and, they ask you, based on this or how close it is, then you're going to include that number. Okay, you'll do that final calculation. Okay, and we'll pull out some practice problems for that too. All right. Yeah, and I gave you a grid in, right? Did I give you this grid in one? Did you do it? Yeah. And I gave you the answers to it, right? Yeah, okay, good. All right. Then the next thing we need to talk about on here is regulation of population size, and you need to get the difference between these two, density dependent and density independent, okay? What do you think disease is most likely? Density dependent, because you know when you have a higher population and you're all crowded together that it's easier for disease to spread. Tornado, independent. Drought, independent. So you know the difference. Usually the density independent ones are usually what? Abiotic or biotic? Yeah, they are usually abiotic, okay? Whereas the density dependent oftentimes are biotic. That's also when you look at competition that might not only be within the population, but competition in communities as well, right? How another population is influencing it. Okay, so those were just a bunch of slides about that. A bunch of slides about that. Okay, then we finished up with our selected species, right? These are small, you know, lots of offspring, short lifespans, not a lot of parental care. You could write an essay about that, right? And give me an example of that. Whereas when we look at case-selected species, these are large, a lot care for the young, small numbers of offspring, tend to be competitors, not colonizers, right? Those are some of the characteristics. Are you okay with those two? That to me seems really easy. Are you all right with that? Okay. And then I went and talked about human population. We just want to look at that there is exponential growth. We want to understand this term, zero population growth, which I think is pretty easy. And we compared MDCs with LDCs, and we also compared those to age. We put an age structure diagram on those, right? LDCs tend to have a what? What shape of age structure diagram?
Oh, it's a pyramid.
A pyramid, yeah. Less developed countries tend to have the pyramid. A more developed country tends to have that stable age structure diagram. And I think that was that. And we talked about resources. Okay. I gave you several ones on here, but I think everything on here, I might need to bring up the. I might just need to bring up that worksheet because I don't know that I'm going to see it. Okay. Okay. Okay, stop, swans, stop. Okay, swans. How many swans? Tell the person, stop growing. I'm making you smaller. I promise you I'm making it smaller.
Oh, there it goes.
She's very slow. Tell the person next to you, did you get a chance to do these? Because if you didn't do them, that makes it hard when I go over it. And I gave you more. I gave you a ton. And also, I put in there so you would look at it first. I put *00 in your resources. And it talks you through how to do these kinds of, and why each of the numbers is. So that can be very helpful.
Can you go over the one with the dandelions and like...
Is that one of the questions in here or a different one?
I think so.
You don't like the answer to the dandelion one, right?
It was
the last one?
Yeah.
I disagree with that answer.
I was just confused.
I think it is confusing, and I don't like the last answer, the very last answer of the, look, I'm not even touching it.
Like what?
Minimum zoom.
I'm going to go through, don't worry about the last one, because I think when I did it, let me look, can I tell you that one?
Yeah, because I looked on the notes and I saw like what your answer was and I got that same answer, but I was just kind of wondering if you could explain
Yeah,
it.
sure, absolutely. Let me see if I can find it since I can't find it on here. Here, we'll pause this while I find it so it's not boring these people. Hang on just 1 minute.